Example 2, 2x minus y minus z equals -1, negative x plus 3y minus z equals -3, negative 5x plus 5y plus z equals -1. Again, getting rid of z is easy here. I combine the bottom two equations, a plus z and a minus z are going to cancel. So negative 1x, negative 5x makes negative 6x. 3y plus 5y is going to be plus 8y. And negative 3 minus 1 is negative 4. Once again, everything divides by 2, so I would probably do that. So there's one of my equations. Negative 3x plus 4y equals negative 2. If I combine the top equation with the bottom equation, negative z and positive z are going to cancel again. 2x minus 5x is negative 3x. Negative y and positive 5y make positive 4y. Negative z plus z cancels, and negative 1 minus 1 equals negative 2. There's my system of equations. And what you'll notice is I get the exact same equations, which implies that those are the same line. We have a situation where we have a dependent system of equations like we saw in 9.1. Okay. When this happens, and I can go ahead and go through the process here, plus, minus, plus, cancel, 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 0 equals 0. So everything cancels out. All right. We want to create an answer to this problem, and a C answer to this problem. I can say x equals c, I can say y equals c. Or I can even say z equals c, but I have to make a new two-variable equation with z. So I want to go with either x or y. I'm going to go with x equals c. There's no magic to that, it's just you pick one. Okay. If x equals c, I go back to those equations up there. I'm going to take negative 3x plus 4y is equal to negative 2. So again, it says negative 3x, but we're calling x c. We're getting a c response for each answer. So x becomes c. Now I want to get y equals something about c. So move the 3c over here. 4y is equal to 3c minus 2. So y is going to equal 3c minus 2 divided by 4. And finally, once I have an answer for x related to c, an answer for y related to c, I now have to get an answer for z related to c. I can go back to any one of them. I like this one the best. I like plus z better than minus z, if I can avoid it, minus. So I'm going to put x and y in for that. So I'm going to get negative 5c plus 5 parentheses 3c minus 2 over 4 plus z is equal to 1. If I simplify that, I'm going to get negative 5c plus, it's going to be 15c, oh negative 1, thank you. 15c minus 10 over 4 plus z is equal to negative 1. I would probably multiply this whole thing by 4 to get rid of the fraction. I'm going to get negative 20c plus 15c minus 10 plus 4z is equal to negative 4. Now everything that isn't z comes over to the right hand side. So I'm going to get, that's a negative 5c right there, right? So it's going to move over to the plus 5c. And that's a minus 10 becomes a plus 10. So altogether I get 4z on the left is equal to 5c plus 6 divided by 4. So my answers in terms of c are x equals c, y equals 3c minus 2 over 4, and finally z is equal to 5c plus 6 over 4. And again, if the book used a different value of c, you can create an answer, and then let's say they said y equals c, they get some c answer, right? Okay, so what you do is you create an ordered triple with a specific value of c. I would probably go to one of these two to figure out something that makes it divide evenly, so it makes a nice pretty number. For example, 3 times 1 would be 3 times 2 would be 4, right? So if I let c equal 2, this will be 6 minus 2, 4 over 4 is 1. So C2, that's 1. And 5 times 2 is 10, plus 6 is 16, divided by 4 is 4. So 214 would be a correct answer. And then if I let y equals c, then your y is 1, so you pick 1 in their order triple, make sure it makes the same 214 order triple. Again, that's how you verify your solution.